before Jupiter, I can see the sky pulling the stars closer to the dark. I feel it falling through my hands as I renounce all forms of undress. And if there's water on Mars, you'll find me drowning, thirsty for Jupiter. This is a poem by, gosh, I actually have no idea, but you know what? You can find it on the magazine Callosum, Callosum. More importantly, who is this voice that's talking? It's me, Shen. And welcome to SG2 on Space. As you guys know, SG2 on Space is the only weekly space show with myself and Dr. Leonard Kramer, which here we go. This guy here.
Come on.
There we go. I got it right. How are you doing?
I'm good. I'm better. Like I said, I'm better than I deserve.
Yeah. Okay. Dr. Leonard Kramer, who's better than he deserves. Before we jump in the show, realize that if you guys are watching on YouTube, great. If you're watching on Facebook, it'd be at facebook.com/The Shen Show. Our platform has moved to YouTube since about a month ago. So for the at least last 3 episodes, the main streaming platform is on YouTube. I got to thank you to our supporters and patrons, Kyle Baker, Sam Welsh, and of course my former producer for about a year and a half, Atum Ra. So with that all said, make sure you support the show on patreon.com/SG2onspace if you enjoy the show and would like to support our efforts. With that said, let us actually jump into our main topic. This is episode 171, if you can believe it.
Wow.
All right. Yes, I can hardly believe that. Are you frozen?
No, I'm here. Am I frozen?
Okay.
No.
You seemed momentarily frozen, but that's all right.
So did you.
So I wanted to talk about there's so many things going on in space these days, but I kind of figured that we could the topic I wanted to talk about was on
what?
Jupiter, the European Space Agency mission JUICE.
Oh, JUICE.
Which has a
JUICE.
Yep, it has a very interesting acronym, right?
Yeah, I don't even get the acronym because it's like Jupiter Icy Moon something, right?
Jupiter Icy Moons Explorer.
So how do they get juice out of that?
I actually don't know. That's actually a really good question.
So it may be French. It may be a French acronym.
It may be, since it did. It launched from what is that? It launched on the Ariane 5, right? From French Guiana.
Yeah, the penal colony of Devil's Island.
Exactly, in South America.
Former penal colony.
Right. But aside from that, just talking about like why are we actually going to Jupiter and what are these Galilean moons? I mean, just from a science perspective, Leonard, do you know?
A Galilean moon?
Yeah, like what is that?
Well, I don't know. Galileo, he lived in the 17th century, late 16th and early 17th century. He became a professor and he got a telescope and he started looking at one of the first things he looked at was Jupiter, and my gosh, it had like little other little planets around it that when he first looked at it, he saw these little dots, little dots, and those were the moons, and he thought that he watched them, a night after night, and they move quickly, right? So in another night they're in a different position, and so these were the moons around. He gradually came to realize that they were in orbit around Jupiter, and it kind of prompted him to get to the idea that the solar system was kind of arranged that way, with things orbiting around each other, and even the Earth orbiting around the sun. But I digress. Those things that he observed were called are called the Galilean moons. I think there's 4 of them. But this mission is, and I've seen them myself. If you have a telescope, they're not difficult to see. And
the Galilean moons, for those interested in Greek mythology, which you are, right, Leonard? They're named after. They're named Io, Europa, Ganymede, and Callisto.
Mm-hmm.
which I
Well,
are
yeah, they are characters from Greek mythology and Roman and Greek from Homer and so forth.
right.
So yeah,
So these are, I suppose, roughly. I mean, they're kind of images, right?
right.
Io, Europa, Ganymede, Callisto.
Io was pretty spectacular when it was first discovered because there were these sulfurous volcanoes that were erupting from it, and I think it was first viewed by up close by Voyager in the late 70s or early 80s, and it looks. I know it looks like a badly cooked pizza without any toppings. That
Yep,
maybe it may have been dropped on the pavement a few times
that's
before it
exactly what it
got
looks
to your
like.
door. But that's all sulfur and all kinds of sulfur stuff, sulfur chemistry that's going on. And it's thought that there's liquid sulfur inside, and that it's being heated by a gravitational interaction with Jupiter. So in other words, the tides on tidal forces from Jupiter are kind of stretching it and pushing it around and causing it to heat up. And there's a few volcanoes that can be seen there. So Io is a pretty interesting um, moon of Jupiter. So, and this is Europa. Now, Europa is evidently that's ice. That's water ice.
What are all the random lines crossing around?
Well, it's thought that it's the same effect that this is a surface crust of ice, and underneath there's liquid water, and maybe there's a source of heat inside from either remnant heat from the formation of the solar system, in addition to also the tidal forcing that I mentioned in regard to um, Io. So there's all these cracks on it. I don't know what the orange. Here, go on back to the picture. I don't know what the reddish material is. I'm sure that that's been studied. So that's an important factor as well. But the cracks appear and then they fill up with the liquid underneath. So there's water there. It's also
This
a go on. Yeah.
No, I was going to say this particular image was taken apparently back in 1996.
Oh, ancient
So
history. Yeah. Of course.
yeah,
um,
on board the spacecraft that was actually called Galileo. So
yeah. So actually, this mission that we're sort of talking about is sort of a follow-on mission that was sort of stimulated by the discoveries that came from that probe, the Galileo probe. That was a
talk
one.
about what about Ganymede?
So Ganymede, I don't know as much about. It's also thought to be an icy moon and thought to have liquid water, and that's one of the targets of this mission is to study this in greater detail. Ultimately, the JUICE mission is going to, end up around that. And so
And I guess this one's Callisto.
Callisto also I don't really know. It's obviously has a lot of impacts on it. So
This so I mean this youth mission, as far as I understand it, is going to go to every single one of these except for Io.
Yeah, so that would be 3 out of the 4, if I'm
right.
Yes. So Io is pretty well studied, and we don't think that that's a water ice place. But the other 3 are it's up in the air whether they have liquid water. We're pretty sure that Europa is a liquid water. There's liquid water inside, which is exciting. I mean, because there's all kinds of ideas about dropping a probe, dropping a lander, and then different kinds of technology that could be used to bore through the ice. We'd have to go several kilometers down, which is maybe easier on a moon than it is on the Earth to bore down into because it's not as it's a smaller body, and then maybe drop some drone type submarines inside.
Right.
Maybe
That
there's
would be a complete.
yeah.
That would be really astounding.
That would be
For sure.
astounding. So this mission that we're talking about is going to last about 11 years. It was launched Friday. And no, about 12 years. It's supposed to extend until 2035, and So it
But
has
I
what?
suppose one thing that's interesting about it is that it's not going there directly.
Oh yeah, I was about to say. So a lot of the engineering having to do with this spacecraft navigation and so forth is really interesting, because in order to one approach to doing interplanetary travel is to use the gravities of the planets around you to give you a boost. And so this spacecraft is going to be put in an orbit that is kind of almost the same as the Earth's orbit, and next year it will come back to visit the Earth again, and it will use Earth's gravity to sort of boost it into a higher semi-major axis, which has a low apoapsis that actually goes in toward where Venus is, and so then it will get another boost from Venus, which will give it a higher orbit. Here you can see it's going higher, right?
So it
So
does
that
this like 3 times, huh?
yeah. So I think it's an Earth, or it intercepts the Earth, and then it intercepts the Earth again, and then it goes in and goes close to Venus, and Venus boosts it up to Jupiter. That's a really cool simulation there too. So you see it go all the way to Jupiter. On the way, it's probably good. I think that they're going to pass by a comet that was discovered a few years ago, a comet called Rosa. And we don't know anything about that comet, so we're gonna be able to
So
image
it
it.
goes from Moon to Venus. Oh, sorry, not Moon. From Earth, Venus, Earth, and then it spirals out.
Oh
So
no,
it goes, yeah,
okay, maybe I thought it was Earth, Moon. I mean Earth, Venus, then
maybe
Moon.
you're
But
right.
I could be wrong about that. So,
But point is,
but
it's using the inner planets, including Earth, as a means of to
and it
gravitationally,
yeah, and so
yeah,
this is something that's
assist.
been well known. I mean, that this is how the Voyager and Pioneer missions were able to exit the solar system, even in the 70s. So this was this is a very cool um, interplanetary navigation technique. It's not the only way. I mean, we can do direct transfer with very large rockets, but this
Right.
is
Oh,
so
okay, I see. It makes after passing Venus, Juice makes subsequent flybys of Earth, Mars, and Earth again before its rendezvous with Jupiter in October
I
2029.
I'm not sure that's accurate. Does it? Well, it doesn't matter. Maybe
Well, it says here that this is a schedule of what's happening. So
okay. All
on
right.
the official
Well,
site.
that probably, if that's the official site, then we'll go with that. So I'm wrong. It's also going to use Mars as part of the gravity boost.
Wow,
So
that's pretty incredible that they planned this all out. I've also
uh-huh.
heard it's going to have the largest like solar arrays, I think, of
It
any
is a massive
like this
satellite.
thing.
I think they said it's going to be carrying about 1.5 tons of fuel, and then the entire, so how much is I think the whole mission was something
Ugh.
like 13,000 pounds, and I mean the whole vehicle is going to be on, and when it's launched it'll be 13,000 or maybe 13.5 pounds, and that of that about 3,500 is fuel, and so the rest of it is
Mhm.
10,000, roughly 10,000 pounds. So it will have what they call magnetometer, which is a instrument for detecting the magnetic field. It will have plasma instrumentation because Jupiter itself is pretty interesting with its the radiation environment and the magnetosphere of Venus, of Venus, not Venus,
Uh,
Jupiter.
Magnetosphere
The
of
magnetosphere of
Jupiter.
Jupiter is very interesting, and it's there's a lot of energetic charged particles, and it's a intense radiation environment. So the hardware, electronics, and so forth has to be hardened against all of that. Let me see.
We can take a
It
look at the science instruments that are here. What you were saying.
Yeah, so various optical camera systems, ultraviolet spectrometer, there's going to be like a radar, like I think a laser radar or laser
Hmm.
lidar altimeter, which is really a high precision tracking device. And one of the things they're going to do with the laser altimeter is they're going to measure when it gets around each of these when it gets when it gets around Ganymede in particular, it's going to be measuring the height, and that can be related to they want to be able to observe the tides. So if the moon is completely solid,
Hmm.
then the tides will be less than if there's a significant interior
Y-
liquid
y-
component.
you're
So
saying like, so we say all three of these icy Galilean moons, they likely have ocean water underneath, and you're saying you can observe.
well, it's not known. It's not positively known whether Ganymede has
Ah, okay.
that or not. So, um, I'm trying to think of what else I wanted to say about that. The magnetometer also, believe it or not, can be used to sort of detect whether there's liquid inside, because the liquid
Hmm.
usually, yeah. How would that work? Well,
Yeah, how does that work?
how does that work? Well, if it's liquid, then it likely has salt in it, which means it's an electrical conductor. And so when it interacts with the magnetic field of Jupiter, which is a very
Hmm.
intense magnetic environment, and if it's spinning around, it will have the tendency to resist, because currents will flow. It'll have the tendency to resist penetration of the magnetic field through the body, through the physical um,
Hmm.
ponderable mass of the body, and that can be detected as very small perturbations in the magnetic field, with some sophisticated algorithms that can determine that. So it's literally electric currents that are flowing in the water.
That's really interesting. I
Yeah.
never knew magnetometers could detect like
So
in water.
that's one of the things. So my PhD thesis had to do with magnetic interaction with planetary atmospheres, and so there was some
Oops, sorry.
well, actually, solar wind, the magnetic field of the solar wind interaction with planetary atmospheres. So that physics is pretty well known, and indeed, that's one of the things that can be done.
What is the?
So
Do you know what the particle environment package is?
I have no doubt that is a plasma experiment. I don't know for sure, but that appears to be a plasma experiment to investigate and measure temperature and constituents. The
Hmm.
particles that are in the Jovian. Jovian means Jupiter's
Hmm.
environment. So that the planet, the moon Io is spewing sulfur into the environment, and so the magnetosphere of Jupiter is sort of filled with sulfur sulfur ions, and so it would be interesting to see what else is there. I don't know that there's been any very high resolution plasma experiments, and so this is this is a very ambitious
That is really
um,
ambitious.
experiment, and I'm hoping that it will be successful.
So at the end of the day, with all this, what are we actually gonna? I guess what do we expect to discover? Well, we
Well,
don't know, I suppose.
well, I think we don't really know. We hope that one of the main targets, of course, is what is the extent and depth
Hmm.
of the interiors of these moons. Jupiter itself is something very interesting to investigate, and in fact, part of the original the 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 initial encounter with Jupiter will put it in orbit around Jupiter. I think they're going to use one or more of the moons to change the inclination of the orbit
Hmm.
of the spacecraft, so that it's polar, and so it's going around the pole of not the not the moons, but
Hmm.
Jupiter. So it will be observing Jupiter. Jupiter's an interesting place. There's lightning there. There's aurora. The nature of the clouds is not completely understood. So there's a lot of things that can be observed, and also the radiation environment. So that's what they would hope to be able to investigate.
This is also going to be is this like a precursor, not precursor, but there's also the NASA
So
Clipper mission that's going there, right?
there's another mission, and I forgot the name of it, but it will
Oh,
it's going to launch next year, and I
mhm.
think I I I don't know when it arrives, but
I
it
think it's
will.
a Europa Clipper.
Europa Clipper, and NASA has, the United States has some stake in that as well, in that mission. So this one is fully a European Space Agency. I mean, JUICE is fully European Space Agency project, but this other project will arrive. This other spacecraft will arrive, and I don't know as much about that. I haven't studied as much about that, but I know that they will be. It's an orbiter, and it will
JUICE is
it will.
the European one, and then the American one, the NASA one, is Europa Clipper. And
Yeah,
we
that's
also
it.
currently have what is the one that's right there at Jupiter right now? I forget. Juno. That's still there,
Juno.
right?
Uh-huh.
Yeah.
Yes. Yes.
So
So we're really studying Jupiter. I mean, it's like I've watched this, my entire life. I've watched the space program, and this is what's
85 meters squared solar wings. I guess they have to advertise that. That's pretty huge.
that is
And
pretty
then
big. I
35
really
Juno.
I really think a nuclear reactor is the way to go. But
Why are they building these spacecraft with gigantic solar panels?
well, because we're so much further away from the sun that we need bigger solar arrays. I think I read that it's an 800-watt system, that they need 800 watts of power, which is a lot.
Right.
And so they need a very large solar array, but it's kind of like not practical if you go very much further away from the sun than Jupiter. It really would be better to use a nuclear reactor, and we just need to get people used to that idea. Take another decade or so before, because naturally any kind of thing that's new scares people, like microwave ovens. Did you know that microwave ovens were scary to people when they first came online, and a
I,
lot of people didn't want to use them. They didn't want to put their food in them.
are you saying they thought it's going to get irradiated and then we're going to die from radiation?
Yeah, yeah. I've even met people who were afraid of radiation from computers. They didn't want to go in the same room with them because of
Right.
so there's all kinds of things. But so,
Do
but
you see this?
no, I
That's
didn't
that's
see this. I didn't see this. But this is okay. So this is the deploy. What are we doing? Are these?
these are, I mean, it's kind of a slideshow, right? This is when Juice left Earth and it took a selfie of himself and Earth.
That's
You know?
Somalia right there. That's
Yeah.
the Horn of Africa, and
And then
Saudi, and the.
this one is a different view. I'm not quite sure where. It looks like probably some maybe Pacific Ocean.
Yeah, I don't know where that is.
And then this is I guess that's when it's deploying its solar panels. You see that? The 85 square meters.
Uh-huh.
So that's yeah. It's kind of,
Fantastic.
I
Yeah.
know. That's a gigantic, solar array.
Yeah,
And then
it's a great. This is a fantastic time to be alive. That
the longest antenna awaits deployment. Um, I guess it needs a really long antenna to talk back to Earth eventually.
I think no, I think that antenna is some kind of radar system, but I
Oh,
could
is
be
it?
wrong. I could be wrong about that. The antenna that they would have to they have to deploy an antenna for communications, but that's usually I don't know what that antenna is.
Okay, I mean you might be right. I'm not quite sure myself. But
So
yeah, sorry, go
anyway,
ahead.
no, that's all. I like I said, I don't know a whole lot about it, but we're just coming up to speed on it. Yeah.
Definitely. How is if humans are ever going to go to Jupiter, are we going to have to worry about the amount of the magnetic fields and such and
We're gonna have
radiation
to
coming
worry
from
about the
Jupiter?
radiation environment. Yes.
Right. So
So,
why does Jupiter is not like a star? So where is that radiation coming from?
oh, the radiation is coming from trapped particles from the sun primarily.
Oh,
So,
it's getting trapped in the magnetic field of Jupiter.
right, and then accelerated by the mechanisms that are occurring inside of this rotating thing, the atmosphere rotating in the magnetic field. So
Oh, okay,
they
I see.
so there's trapped particles and they become concentrated and accelerated. Just like in Earth. I mean, the Earth has a radiation environment also, these so-called radiation belts.
Right. Yeah,
And
makes sense.
it's a result of the intense magnetic field. The magnetic field itself, if it has a magnetic field, that means that there's a there's liquid thing, there's something liquid inside the core of the planet, and that it's rotating, and it produces a dynamo, which is not completely understood, but we do know about that.
Right.
Almost all rotating stellar and planetary scale objects have magnetic fields, and if they don't, it's because they're frozen. It's because they have solid cores. So the moon doesn't have any significant magnetic field, and that probably tells our moon, and that tells us that it has a non-conducting, or it has a solid core. So there's no dynamo. There can be remnant magnetic field, permanent magnetism, like at Mars.
Hmm.
Mars exhibits that. So, but
This is
the outer planets, the giant planets, gaseous giant planets like Jupiter and Saturn and Uranus and Uranus and Neptune, they all have intense magnetic fields, and that's because um, they have liquid conducting matter inside of them.
it will fly past Callisto 21 times, but only fly past Europa twice before settling into orbit around
Yeah,
Ganymede.
yeah. I think we're not as interested in Europa, but
For this one at
yeah,
least.
because it's already been kind of observed. But
Right.
Ganymede has not. It has not been there. I haven't seen very many headlines with Ganymede in them.
Well, I mean,
So,
it's interesting that this one's apparently going to settle into orbit around Ganymede. So that's
yep.
and Ganymede is the largest Galilean moon. So
Right.
um,
hmm
it should be quite interesting to see
So
what happens.
here, go back to
Wow,
that picture of Jupiter. See, it's got
right here.
see there they. I don't know if this is a photograph or artist, probably artist rendition, but you see at the pole or they've depicted aurora. That's auroral activity at another
It
planet.
is artist
Yeah.
impression of the Juice mission
Uh-huh.
because clearly the spacecraft is not there yet. So
Yeah, so it would be difficult to take a picture sometime in
I
the
don't
future.
this picture would only be able to be taken if there was another spacecraft following it, taking it.
That's
So
true. Yes.
definitely an artist rendition.
Mhm.
But what is that thing around the Jupiter's poles right there? Is that
Okay. All right. So you know, you're like a millennial, or so you don't really listen very well. So I
Mhm.
just said I just said that that's depicting the Saturn has an auroral. I mean, Jupiter has an aurora in the thing. So that's what that is.
all right? So my apologies. Instead of trying to look up stuff, I should actually pay attention. After all, we're talking about a space show, and why am I not paying attention? Uh, how embarrassing.
I'm just kidding you.
But you're right. I mean, to give you some context, that great red spot I know of Jupiter can fit 3 Earths there. So that aurora is more massive than like
Yeah,
probably 2 Earth size.
right. So
So
it's yeah.
it's
So
the
we
yeah.
we could actually do a show on the Great Red Spot at some point. Just the spot itself. I mean, so I mean, it's so
We should.
wild that there's this storm that's been going on for at least since Galileo. Galileo observed that red spot, and
That was in the 17th century, so it's over like 400 years ago.
Yeah, let's say it was about 1620 or so.
Yeah. I mean, that's pretty incredible to have that storm there for over 400 years, possibly.
So we don't, and you have to think about it. What preserves that? What is the fluid interaction that's going on there that keeps it from just being torn apart and spread out? I really don't know. We ought to do a show on that so I can study it and learn about it.
Definitely. I think we can definitely talk about that in the future for sure. These kinds of phenomena. I mean, there's so much that we observe, but we don't understand the reason for it, right?
That's one of them. Yeah.
So, do you want to move on to one of my favorite topics?
Absolutely. I
wonder what that could possibly be.
That might be. I don't know where your favorite ice cream factory, or
what could that be? I mean,
so
I don't know.
I don't know. Why is your head so big?
What? Jesus, why is my head so big? Okay. If I play this video, it's not going to have any sound, which will not be good. So, one moment.
Sure it is. Silence is golden.
Since I have to, I've realized that in StreamYard, I can only share, what is it, a tab, right? Like, okay, so if I just stop.
I don't know. You know more about it than I do. I don't know. I've tried to figure it out.
It is interesting how maybe that's not how it is. Share screen.
Are we really on YouTube? Where's my phone?
We must be on YouTube.
Yeah.
Okay. I'm not sure how well this will work. We can certainly. Oh no, that's not a tab. That is actually the whole.
Take your time.
The window.
Take your time. The audience isn't getting bored.
Are you sure? You can tell an entertaining joke if you have one.
I don't have any. I want to see if we're really on YouTube.
This one's actually. You know what? I mean, some of these are like rather hit or miss because I don't want to see one where it's just this guy like talking. I want to see something that's actually real.
What is it you're looking for?
Well, Alien. There was this
Alien.
Yeah. So, I mean, this, I want to actually see if there's, nope. Like, if it's just a bunch of pictures of somebody talking, that's not really that entertaining, is it?
We are on YouTube.
I know. Are we not?
I'm gonna tell my friends.
I found one. That's in Ireland. That happened last month. This one's great because there's no talking. Because I don't like a random guy talking or a robot voice. Says, all right. Let's see what we got. Shall we?
Shall we? We shall. Shall we?
Okay.
Let us.
Oh, hold on. Share screen. Share.
Hey, I have a bottle of wine in the kitchen. I just noticed that. Anyway. Oh, so what's going on here? It's the moon.
I don't know. This is somewhere in Ireland. I mean, come on. That's obviously a UFO, right?
Well, I haven't identified it. One appears to move in front of the other. Well, but it's got the blurring technology. And it went out. So that's the moon, and it's an almost full moon, which means the sun is behind us. So it's not a satellite going into. Well,
here, let's start again. This is in Ballymahon, Longford, Ireland. So, a pair of lights blink in and out of the night sky.
They sure do.
All right, so let me just read the actual news article.
It's chilling.
The person on Monday, so this was on March 10th, 2023, reached out to a local publication. They said that they spotted unusual activity in the night sky over Ballymahon in Lanford. The person in question also told the publication that he had recorded the incident that he saw around 8 p.m. The resident said that even though the photos are a little blurry, the movement of the three lights in the sky was very clear. They moved very quickly and formed a triangle.
What else? What else?
UFOs. The caller, who was with the friend at the time, told the I guess the publication, the leader, that oops. Oh, did it just go to cosmic relaxation? Oh, that was weird.
I don't know.
Yeah. So the photographs do not do this justice. It was very clear that night. The three lights were on the angles of the craft. The body was black. The lights were the color of an orange flame. The speed that they moved at confirmed it was not an ordinary aircraft.
Okay.
The person insisted that living in the countryside, they are used to seeing. He's used to see shooting stars, meteorites, satellites, and more. However, the lights that they saw was, it's very different.
They're in front of the clouds, apparently. Although maybe that's debatable. I find the narrative to be more compelling than the pictures, actually. So, I mean, it just seems more like a lot more detail is in the narrative than there is in the. So
it is true. Like they do suddenly disappear. I mean, how do you explain that? Like, it's like, wow, it's here, and then they're gone.
They turn their lights out. I know.
Oh.
They knew they were being photographed, so they turned their lights off. But okay. If it's a silvered object like a Mylar balloon or something, it could turn, and I don't even know why it was illuminated and what the source of the light was in the first place. So I don't know. I just don't know. But what am I supposed to say? I mean, so they're aliens? I don't have the.
No, that's a conclusion you can.
Aliens is not a conclusion that I can come to from just that.
I agree. I mean, nobody said you have to say it's aliens. I mean, heck.
But it would be fun if I did, wouldn't it? If I said, "Oh yeah, that's very."
That would be very surprising to me, considering that you've made your rationale pretty clear on the fact that you think humanity existing is like a 1 in a gazillion probability.
A gazillion, yeah, 1 in 10, 1 in a gazillion. That
gazillion.
I don't want to use I don't want to use the term irreducible complexity, but I just think that getting from nothing living, abiotic matter, to a ribosome reading DNA or reading an RNA strand to make proteins is just so improbable that a priori it didn't happen. It didn't happen in all of the universe, although it did happen. So it was a fluke. It was that's. But I don't have an analytical explanation for that. I'd like to make contact with someone somewhere in the academic community, who's interested in those things, to see if we can figure out how to determine the probability of those things coming together on their own. And I think that it would be. I think it's the limiting factor in the Fermi equation. The Fermi
paradox.
The Dirac.
The Drake equation.
The Drake equation, right? Excuse me.
So I think, which is a topic that we have went into in the past. So for all our viewers out there, definitely, if you're interested, look up Drake equation and look at episode number. I don't remember, but I will share it later. But we had an episode where we specifically talked about this, and Leonard expressed this.
I am a very unpopular guy because of this opinion. Okay.
Well, I mean, it makes sense when you think about it from the biological perspective. But I think at this point in our show, we gotta call it a wrap.
We do.
Because look up, because you never know what you will see. Who knows? With that, I will play some ambient music, which unfortunately you guys cannot hear. But that's all right. You can imagine you're floating through space, right?
Oh, well, why can't we hear the music?
I mean, because can you hear it now?
I almost did. So this is a limitation of our technology here, or maybe it's just we don't know how to get the sound.
This, I think it's a limitation on the browser. For some
Oh,
reason, it doesn't seem to work so well when it's not Chrome.
oh,
And
I
I
see.
did not realize that.
Oh,
So,
oh
but
yeah.
that's fine.
You're crashing at your friend's house because the traffic was really bad,
Yep.
and so
All right.
so
That's
okay.
that's a consequence of that, but that's all right. Any case, look up because you never know what you will see.
That's right.
This has been SG2 on Space, the only weekly space show. You can find us on
That's right.
www.facebook.com/the Shen Show,
And
and of course,
you should like and subscribe and all that good stuff if you can.
yep, like, subscribe,
Yeah,
all that good stuff. Thank you to our current supporters and patrons. And of course, support the show, www.patreon.com/SG2 on Space. We'll be back next Wednesday live at 6:30 p.m.
you
U.S.
betcha.
Central Time to talk about something very exciting.
That's right.
Maybe the red spot. Who knows?
And good night. Mwah.
Mwah.